Hey friend, and welcome back to the channel. Today we're gonna do a data science full hands-on project from data scraping to data analyzation to visualization to machine learning and prediction all in one video. And today we're gonna analyze a football data set. Let's jump into it. So first, we're gonna analyze a football data set as I mentioned. So a quick overview about it will be, we're gonna just analyze the Spanish Championship, La Liga, for the past 10 years, and based on these historical data, we'll try and predict who's going to win this year's La Liga. And we also want to know who are the two teams that are going to be relegated at the end of the year, and also who is going to finish 7th in La Liga, who is going to play the Conference League. So we're going to answer all of these questions, but the assumptions here is that we want to know who is going to be the winner of this year's La Liga based on 10 years historical data. Next, we're gonna do data scraping. We're gonna go and we're gonna scrape the data ourselves, bring it into our development environment, and then we're gonna analyze it. We don't have a data set yet, but we're gonna create it by scraping the data from the internet. We're gonna do this everything hands-on together. Then we're gonna explore the data. When we bring it after scraping, we're gonna see what it looks like, what are the features, what can we use, what should we avoid, and all this fun stuff. Then we're gonna jump into data analysis and visualization. And this basically is the part where we're gonna talk more about what can we analyze, what features, what should we visualize, what are the KPIs that are interesting overall. And finally, the cool thing, and I made a mistake there in machine learning, it's not machine learning, it's machine learning and predictions. So we're gonna build a machine learning model, we're gonna use a decision tree. We'll see that this prediction is quite a straightforward one because the attributes that we're gonna use determine really well the output, but it's gonna be really fun. We're gonna do all this together. And you can also do the hands-on with me. You can start the project, follow along with me. We'll start everything from scratch. Let's jump into it. Okay, so first, as we mentioned, we're gonna scrape the data from the internet, and there's this really good website called FBref, where we can get all insights about football, whether it's players, teams, anything that is related to football, we can find it in here. And the one that we're gonna focus on, as we mentioned, is La Liga. La Liga is the Spanish Championship, and we're gonna only focus on the past 10 years. So data from 2014 up until this year. And it was just a choice of mine. Obviously, you could do way more than that, but I was thinking that based on 10 years, we could predict the best way possible who is gonna win this year. Plus, this year has been already 28 or 29 games that are already played, so there are only 10 games left. So based on 10 years of data, plus what's going on already this season, we need and we should be able to make predictions on who is going to win and the ranking. And obviously these are probabilities, nothing is set, but we're going to do that all together. So this is the website, and if we just go into this here, for example, we click on it, and we can see that we have a table here with the ranking and some cool features and insights. So when we're going to scrape the data from here, we're going to grab this table and just bring it into our environment. We can use Python to do it with pandas, and with pandas we can read from HTML. So that's something that we can do. So we're gonna bring this table and we're gonna do it for each and every season. So let's start on it. Here we are in Visual Studio Code. We're gonna open a new folder. So I have this new folder here. I have this football tutorial, it's empty. I'm just gonna drag and drop it in here so we can start a new project. And first we can create a new notebook and call it data scraping.ipynb. And here we're gonna select the kernel. We can use our Python environment, whichever you use. I have Conda in here. Let's do code just to test briefly that it's working. It's working. Let me zoom in nicely in here. All right, you can see the file. Let's do this. So first of all, in order for us to scrape the data from the website, we'll need to be able to find the specific position of it. So if you click right in your browser and you can do inspect element, let me just keep this bigger. We have this button here where we can select, and we can look for the table. So if we can see here, we're able to click on the table, and we can see here that this specific part on the right gives us the HTML code that we can use to bring this table specifically into Python. And we can see here that we have a specific ID for it, which is results 2024, 2025. So it has some specific code for it. So if we go back and we can do something like df underscore 2024, 2025, because we're gonna have quite a few. And we're gonna do pd.read underscore HTML, because we're gonna be reading the data from the internet. And here we're gonna go and bring the link that we see is the one. Let me refresh this. La Liga statistics. Okay, we're still just in here. So we'll need to go to the specific page. Let me go first to the specific page where we get the La Liga insights. All right, so this is the one. Okay, so in this link here, we have the 2014-2015 season, the first one that we're gonna start with. And here we can see the table that we have. We do the same thing. We do inspect, go and get the table. Here it is, we have the ID and we have the link. So the link is important to start with first. So we do this and we're gonna put on the link. Then we're just gonna add attributes. And the attribute is the ID that we saw on the website. So here we see Copilot is giving us the syntax for it, so we can just open it. But in here, we have to go back, and this is where we get the ID, is this one here that we see. The ID, we can copy and paste and just put it in here. So that was the correct ID. Let me do this to make it a little bit cleaner. So here, if we press enter, the code went well. So this one here is just to give it to us more of a columnar as a table. And here, if we open it, if we just open this data frame, we should be able to get the table in our environment. So this is as easy as this. We get the link from where we're gonna extract the table, which is this one at the top. Then we just go inspect, go to where the table is, grab the ID, and then you just go in pandas and you input this information, the link and the attributes, which is the ID basically, and we do here 0 so that we get the columnar information. So if we didn't do it, for example, we might get a result that looks like this, but in this case, you can see here we have even more information, but it's not nicely structured, but the way we do it like this, and here we are. It looks beautiful, same as we had it in the website. And then we can go and look for the others as well. And for example, here, we can look for the other seasons, and we can just go and we can see 2015, 2016. And the interesting thing that you'll notice quickly is that the link is the same. We just changed the date. It was 2014, 2015, and now it is 2015, 2016. And even in the ID, if we're gonna look for the table's ID, we're gonna see that the ID also has the same numbers, but one more year. So this gives us a pattern. If we don't wanna do each one manually, we can just adjust the years and we're gonna get the results. Let's do it right now. So if we do this, we just copy and paste it, and then we just update the numbers and we're gonna get the results. Whatever we see 2014, we replace it by 2015, and so on and so forth. Let's do it quickly. Let's run it. And now if we do this one, it's gonna open and work. So this is how we're scraping the data. And to save us time right now, I'm just gonna bring, copy and paste it all. And here we can see we have from 2014 until this season, which is 2024, 2025. We're gonna run it and we can see now that it's running, and within a few seconds we'll have all the data sets in one place. What I would suggest afterwards is to save all of these data frames into CSV, because sometimes if you do too many HTML calls to the website, they might block it. They might block your IP address. And it happened to me, so I'm just giving you this tip, but we're gonna do all of these all together. Next, what we can do is concatenate all these tables. So we have 10 years worth of data, 11 years, and we want them to be in one table. We don't want to work in separate tables, so we're going to just concatenate them. So it means one table, we put it on top of the other, and so on. And since we have the same columns, it's the same structure, it's easy to put them one on top of the other. So what we can do first is that we can first just create a list here where we're gonna put all of our data frames, and then we're gonna just standardize it so that all the columns of the tables have a standard name. We're gonna just remove the uppercase, we're gonna just remove all the underscores just to keep it clean, so that when we concatenate, it recognizes that they are the same columns. In case there is one column that was spelled maybe with an uppercase at the beginning and then it was lowercase, it's always good to have this. And then we're gonna just go and get the columns that we have. So we're gonna just go and get the columns, the ones that we're gonna concatenate on. And if you wanna have a brief look in here, let's just go and get this one and just do .head, and we can see all the columns that we have in here. These are the ones that we're mentioning here. And then we're just gonna do the concatenation. So now we're just creating a function here. We're just saying for df and year in zip, where dfs and years, these are the two attributes that we have and parameters that we have in here. So dfs are all the data frames that we have, and years is just a list of years between 2014 and 2025. So we're gonna loop into it and go through each and every data frame and every year. And in the end, we'll get the full data, which is here pd.concat, which is concatenation, one table on top of the other. And it's gonna give us the full data frame afterwards. So if we do this, we do print.shape, always good to see the shape, and then we do .head. And here we can see that the shape is 220. We have 11 seasons, 20 teams per season, and we know now that we have the full data in here. So we can see here that we have these three dots. So we see that we have these three dots, and what we can do is, if we want to see all the columns and everything, we can just simply add this code in here, and this one will just let us see more columns and more rows instead of limiting the visibility like we had before. So here, instead of having these three dots, we should have the ability to see all the columns, and it's very helpful, especially the columns, so that you can see all the features, all the attributes that you can use. So now we finished scraping the data. We have the 11 seasons that we needed, and we just wanna save them so that we can reuse them in a new and clean data set. So what we can do, we just put full_data to CSV. We're gonna save it to CSV. We give it a name. A descriptive name is always better. So 2014 to 2025, and we just print the message that it was saved successfully. So we just do it, and boom, it's all there. And we can see here in our files, we have this La Liga data 2014, 2025. Next, what we can do is we can do La Liga data analysis.ipynb, and this is where we're gonna now go and do the analysis, the visualization, the machine learning. So the first part was data scraping, and we went through it. Well done if you're also doing the tutorial with me. If not, you can watch and at some point do your own hands-on, but it's always beneficial to do these things because you'll encounter a few bugs, and it's always good to try and redo these things yourself, whether you're using the same website or you're using another one. So that's completely up to you. So to start here, we're gonna select the kernel, our Python environment, and I wanna first emphasize on the hypothesis. So the hypothesis is very important because we need to set a hypothesis that will guide our analysis. Without a hypothesis, we'll be just randomly doing things that have zero benefit. Here, our hypothesis is, given the current state of the table and past seasons, what's the realistic probability that each team could still win? And this one will base our analysis and predictions. We want to analyze previous data set, and we want to predict who is the team that is going to win this year. And not just that, we can also look into something like specific and just say, let's do it like this. Who is most likely to win La Liga this year based on previous 10 years? who are the 2 teams that will most likely be relegated. As you can see, I'm using most likely because it is just a prediction. These are probabilities. And who is the team that will most likely go to Conference League, which is the 7th position of La Liga. So we have set our hypothesis, and then we can, okay, start thinking how we can do this. So we can just go, and first we're gonna obviously import Pandas as PD. Pandas will help us do all the analysis, all the exploration, cleaning and everything. And we can also bring our CSV file that we just saved before. So we're gonna do pd.read_CSV because now we have a CSV file, and we can just do, like I usually do, .shape, always get the shape, and then just full_data.head. And we can see here that we have our data, 220 rows, so we are in the correct state. Let me just bring in. So this one here is just for us to have the ability to see all the columns and a maximum of rows of 500 here. So if again, let's close that one there. Let's do it here. And if we bring these in here, yeah, we should be able to see all the columns, and that's the goal in there. So here now we can start a section and we just do data exploration, and here we use either a markdown in here or a code. So if you do markdown, you can put on titles by just adding hashtags, which will be a header, a second header, and all these things. So if you do just one, it'll be a big one. If you do a double, it'll be smaller. If you do third, it'll be even smaller, and so on. So you can organize your project really well. Here we're gonna have data exploration, and here we can start first. We can first look at the data. So what we can see in here, we can see that we have, let me do the full season, we can see 20. So here we can see who is the team at the top of the ranking at the moment. There are how many games we have played already. There are 28 match played. So this one is a previous season. So this one is 2014. So it's the full season. Barcelona finished first, Real Madrid finished second, and we have a few interesting metrics that we can look into here. So this is the matches played, the wins, the draws, the losses, the goals scored, the goals conceded, the goal difference, points per game, attendance of the stadium, that's not very important, the top team scorer. If we were to analyze the top scorers, we would look at this data, but we're not. The season, and we see a few here that have none values in them. And those have none values because in 2014, we didn't yet have this XG, expected goals, expected goal assists. We didn't have them yet. But if we look at the latest season that is going now, we can see that these metrics are now included in the realm of football. So it's good to keep that in mind overall. And we also have this interesting one that says the last 5 games, if it's win, 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 or drew, win, loss, and whatever, it's always good to have. So we have 11 seasons in here, and I'm not opening them all because it will be too cumbersome to look at. But if you want to look at this current season and the one before, so this one is from last year, 2023, and we'll see that it's directly then linked to the new season that we're playing this year. So what we want to look at is who is more likely to win this La Liga season based on the data that we have here, which is what's going on this year, plus all the insights that we can get from the past 10 years based on if a team won it before, how close they were, and all these things. For now, we only have 10 games left, so the ranking won't change that much, but it's a good hypothesis to put. First, if we want to just briefly look at the number of appearances of each team for the past 11 years, we can just do full data. We can look at the squad, and we just want to see the number of iterations within the whole data set. So we do .value counts. So we can see here already clearly that there are these 8 teams that played the 11 seasons fully. And what it means is that they were not relegated within the past 11 years. And we have obviously Barcelona, Real Madrid, Villarreal, and other teams. And if they have less than 11, it means that they were relegated at some point. Like if we see here, Betis, they have 10, it means that one season they went to the 2nd division and then they came back. It's interesting to have a quick look at the data to understand what's going on. For some people that are familiar with the championship, they might see this very clearly. But for example, I didn't know that Granada for the past 11 years were relegated 4 times. So that's an insight that we can use. In our case, not necessarily, but that's how we explore the data. And then we can also look at the ranking as well. So if we do something like this, if we look at the same column, the squad, and we just group by the ranking. So we have this attribute, the ranking. So if you're first means you won La Liga, if you're second, then means you're the second in La Liga, and so on. And here what we're looking at is just the 3 rankings, the first, second, and third, who are the teams that have the most appearances. And now we see for the past 11 years, we should exclude this year, but for the past 10 years, we have Barcelona that had technically 5, because now it also counts this year, Real Madrid 4, and Atletico Madrid 1. And then we see the second place, we see Real Madrid 5, Barcelona 4, and Atletico Madrid 2. So this gives us a brief indication of the rankings of the teams, and it's a very interesting insight to have. Here I only limited to 10 rows, because if I kept going, we could see also the 4th position, the 5th position, and so on. But I was only interested to see the first 3, just to have a nice look on what's going on in here. And now we can also introduce a very, very interesting library. It's called Plotly. And Plotly is a visualization tool that I really like because it's very interactive, nicely engaging, and it's very pleasant to also show and present to people. So the way you call it, you just import plotly.express. So you'll need to install the library in your dependencies in your environment. So you can call the terminal and you can do pip3 install plotly, or pip install plotly, depends on your environment, and you just run it in your environment and you download it, and then you should be able to run it in here. So we just import it first, and then we're gonna look at the ranking of the top 3 that we just saw in here. So it's basically this that we're gonna visualize using Plotly. So we're gonna look at the squads based on the ranking, and here we just wanna see the ranking position number 1 and 2 and 3, exactly as we did in here. So here the way we call Plotly, we just call fig equals to px, because that's the diminutive that we're using, dot bar, because this is a bar chart. And here we have a few interesting attributes that we're gonna fill. So we have first is the X and Y axis. Always, when you plot a bar chart, you always have an X and Y axis. So the X are the teams, and the Y is the count of how many times that team ranked in that position. Color here is RK. Colors, you can basically go on Plotly's website and just put all the gradients of the colors, and you can use whatever you want. The bar mode is grouped. We have a title, which is called the top 3 that finishes by team and rank, so the top 3 ranking. And then we have labels, which we're gonna see now that we run the code. So let's do it. And here we are, we can see clearly that we have, these are the top 3 rankings. And if we hover through, that's why I like Plotly, you can nicely hover through. We can see that Barcelona rank equal 1 6 times, rank number 2 4 times, and only ranked once in the 3rd position. Whilst Real Madrid, you can see 4 times first and 5 times ranked 2, and so on. We can see here Girona ranked once on the 3rd place. So that gives us a good insight. If I wanted to just look at, for example, the 7th position to see for the Conference League, and we can here see that the 3 teams for the past 10 years that were in the 7th position at the end of the year were Villarreal, Sevilla, and Athletic Club. If you want to see the last 2 teams of the year, the ones that were relegated, we can also do the 19th and 20th position, and we can see that Almeria and Las Palmas, twice they ranked 19, whilst Valladolid once ranked 20th and once ranked 19th. Just gives us a cool insight on what's going on, and that's the power of exploring your data set before trying to make any assumptions. It's good to understand what's going on, put the hypothesis, do some exploration, do some visualization and analysis as we are doing now, and then we're gonna jump into answering what we want to answer basically. Also, a good rule of thumb is to look at your statistical analysis in here. So if you do full data.describe, you can look at the statistics, and especially for numerical values, you'll see that the other categorical or textual categories we don't see them. We only see the numerical values. And for example, here we can see if there is something missing. We know that the data set has 220 rows in it. So for example, we can see the count, ranking we have 220, means nothing is missing. And for example, here attendance, we see we have 204. We have a few that are missing. It's always good to have this one in mind, because if we're gonna do some comparison or some correlation, it's interesting to know if there's a missing value or not in some cases. We can also see the mean value, the standard deviation, the minimum, the maximum, the quantiles and percentiles, all of them in here, and they can be very, very useful. Something to always have a quick look into. We can find some outliers, and it's always good to spot them very quickly. Let's say, for example, we see on average the MP, which is the match points per game, I assume. Yeah, it's points per game. And this one, no, this one is points per game. Yeah, let's look at this one. So it's points per game, and we can see that usually the minimum is 0.53 and the maximum is 250. And you look here and you see that maximum is 15, which is unusual. And then we understand that there is an outlier, and you need to go and either remove the outlier or sort it out. Otherwise, it can bias your results. So that's something to be very careful about. Next, we can look at the winning teams of the past 10 years. So we just want to look at who is the team that ranked number 1 within the past seasons. Only the winning team. So we call winning teams a variable. We go into our data set. We filter by ranking equals to 1. And here we just keep other columns as well so that we can have a visual. So we can see here for 2014 until 2024, these are the teams that won the championship. We can see Barcelona 5 times, we can see Real Madrid, we can see Atletico Madrid, and we can also see interesting information that we can use. Obviously, this season is still going, that's why we can see only 60 points, but we can see that, for example, Barcelona in 2014, they won by 94, then 91, then 93, and we can already see a pattern that points between 85 to 95 usually guarantee or nearly guarantee winning at the end of the season, but not fully. We can see also points per matches played, and this one is a great indicator. We can see already that the higher is this number, and the more likely the team to win the championship. And that's something we can look into if we just go back in our table of this season, and we see that this is now the ranking at the moment, the live ranking. And if we look at the points per match, we can see that it's going on a descending number, because the more points per match you have, and the more points you're gonna have, and the better you're gonna rank. So this feature directly correlates with the ranking. And it will be interesting for us to see for the previous seasons, what was the average of the points per match at the end of the season for the winning team, so that we know if we can say that Barcelona from now is already pretending for the title or is sure to win the title, or insights like this. And that will be very interesting to know. So if we continue and if we go now and get an average of those. So what we can do, again, we just go and look at the ranking teams that are ranked 1, means that they won the championship. And we want to see all the seasons apart from this one, because this one biases the results a little bit. And what we want to do is we want to check the points per match played and do the mean value of it. And for me to make this a little bit more interactive and clearer, I'll just bring in the data so we can see the columns. So we're just doing rank equal to 1, meaning only the teams that won championships within the seasons that are before this year, so 2014 up until 2023. And then we're just gonna take the points per match played and do the mean value for only the winners. And if we do it, we're gonna get 2.37 points per match played. And this one gives us an indication of how good a team has to be in order to win the championship on average, based on the past 10 years. We could have taken a larger sample, but this is based on the past 10 years. So if we look at our current table, let's say we just look at the top 10 this year. So we're gonna do tail, I'm gonna do tail 20. So this is this year, we can see 2024. We can see Barcelona has 2.22. So it's quite close to the average of a previous winner. Madrid has 2.14. So they're closer, but they're not yet there. So there are chances for the teams at the top to still do it. So that's good to know, just for us as an assumption. Next, what we can do is we can convert the ranking into binary. So what we can do is just here, basically we say we want to create a column. We're going to call it is champion. A champion is a champion if ranking equals to 1. So if we do it, and if we open the data set again and we do .head, always good to always check the data frame to see the new columns and everything. Is always important to do so. And here we can see on the right, the new column is champion, where we have it's equal to 1 for the team ranked number 1, and others will have 0. So if I do it up to 25 rows, we can see it's 1, and again, when a new season will start, again we can see here this is a new season, we can see again equals to 1. So that one will be useful for our machine learning later on. So we keep going in here, and now what we can do is we can calculate the mean of points per match only for champions. So this one will calculate the mean value only for champions, and we can see here that we have 2.35, which is quite close from what we had before, but I assume this one excludes from this year's. So this one is an interesting metric that we can use in our machine learning model afterwards. And what we can do is basically just so we can also use Matplotlib as well as a visualization tool. We saw Plotly, which I use mostly, but we also have a famous one that is Matplotlib, which is also good. It's less interactive, I would say, but for this one, we just want to plot the, let me look at it, this one, the points per match played for the past 10 years, just to have a visual on how it did evolve over the years. And here to briefly look at it, this one plt.figure is just for the size of the plot. This can be adjusted. We're using champions only. So we're only looking at champions only, which means that ranking equals to 1 within the seasons, and looking at the matches, points per matches. We have the color, the marker. These are just basically styling overall. And the label we're gonna put in the mean value, because we're looking to plot the mean value. We have the x-axis is the season, the y-axis will be the points per match played by the winners. So if we plot it, we can see here that we have the first year was around 2.47 and so on and so forth. And we could see that it could go as low as 2.27 sometimes, and or this one here. This one is this season, so this one we shouldn't look at it, but it can go as high as 2.50 overall. And we have a mean value of 2.37 that we calculated earlier. So now that we did some exploration and we did some analysis, we're more familiar with the data, and we now want to answer the questions that we set in the beginning, and it is that we want to know who is more likely to win this year's La Liga championship, and answer the 2 other questions as well. So what we can do is we can basically go and do another markdown, and we're gonna do ML, modeling, and predictions. Okay, so now we're jumping into machine learning, modeling, and predictions. First, we call the necessary libraries that we need to operate in here. So I'll walk you through them briefly. We can see pandas that we've been using for data manipulation. NumPy is to deal with numerical operations and numerical values. The sklearn is from scikit-learn, which they have really powerful libraries that we can leverage for our model in here. We're gonna use the random forest classifier for our purposes in here. We have the standard scaler, which is basically just normalizes our features to make them ready to be used in the model. And then we have here just metrics, and this is just to get an evaluation of the model. In our case, it won't be very important, but it's always good to do these things in your data and machine learning project. So we're just running them. What we're gonna do first is that we're gonna create a few features that we're gonna use. So the first one we call it games left because this season is ongoing and there are many games that were played already, and we need to obviously know how much we have left to make good predictions. We're also creating a new column called projected points, and this one is just for us to roughly estimate by the end of the season what is the projection of the points of each and every team. And this one by itself could be a machine learning model to create, to estimate what could be the projected points of each and every team within the ranking based on 10 years of data previously. So if that's something interesting, you could do that, and this should also give you an indication of what's gonna happen at the end of the season, and we're roughly doing something similar in here. And here we're just again putting on the is champion column that is taken on the ranking 1, meaning only the champions. And we're gonna run this, and we can just briefly have a look and just do dots tail, for example, 3. And 3 here, just the number of columns we want to see. Tail is from the bottom, and we can see already that we have the column is champion, the number of games left, and the projected points. And the way we calculated here the projected points is we took the current number of points that we have plus, and here we do a multiplication of the games left multiplied by the points per match played at the moment. So for example, here if we take this team, Leganes has how many points? 27, and they have 0.96 points per match played. So we're gonna take this 0.96, multiply it by the number of games left, which is 9.6, and we should add it to 27 that we have, and in the end we should have this 36.6. And that's what we did. We created our own logic in here so that we can do predictions. In this case, we're more than supervising the model. We're kind of giving it the brain, we're giving it the logic. So we're fitting it to the maximum, because here the features that we have are really good, and we're leveraging some that have high potential of being accurate. If we just, for example, looked at the losses, the wins, and the goals scored, and we tried to estimate who's gonna win the season, the machine learning model won't be great, and it won't be very accurate either. And here we chose attributes that will give us the best possible results as an estimation, of course. Then we move into training our model. So here what we can do is that we choose the features that we want to train our model on, because we don't want to use all the features. And for machine learning models like this, it's best to use numerical data. If not, it's good to vectorize them into numerical data, and that's why the scalar can be useful as well, which is not used in this case. So the features that we're using is points per match played, the goal difference, the wins, losses, and the projected points, the one that we just created. And here we're gonna do df_train. So in a machine learning model, you'll have a training of a subset for the training and a subset that we're gonna test our model on. So in our case here, the training subset is everything before this season, 2014 up to 2023, whilst the testing will be only this season, because we want to get the results for the current season. And I've put comments on each and everything, so when you see this on GitHub, if you want to have a look and use it, you'll see everything commented as well, and I'll try to refine it even more for you. And here we're gonna just define the features here, as we said, in training. So the training will take on the features that we've put in here only for the previous years, and the output that we want to get from the training, the target variable, will take on is champion, because we want to only define if, based on those features, if we can predict that a team can be a champion. And here we have x test, which will also take on, which we can see here, df_test, but will also take on the same features. So if we run this and we keep going, and now what we can do is to run our model in here. So here, xtrain, and we can see in here that our model, we're choosing a random forest classifier, because here we basically want to define if a team is going to win or not the championship, but we're also going to do it in a probabilistic way, as you're going to see. And here we can see that 200 estimators, these are 200 trees. The random tree is a tree of probabilities, And then the result that we get is like an average of all those trees combined together. And the random state is basically a set number that we just put in here so that whenever we run the code, it will give us the same output because we have this random state fixed. If we didn't have it, then every time you can imagine that the machine learning model will do different calculations and we might get different results. So whatever the number is set there, just keep it, and so that we can reproduce the results. And even if you run it again or you share it with someone, you can still get the same results. Okay, now we can see here random forest classifier. This is what we see in the code in here. And we can do something in here to look at our metrics. So first of all, we can see that here we can do the predictions and we can do model.predict. So first we fitted the model and then we're gonna predict on the training data set as a binary outcome. And here what's interesting you're gonna see next is predict probabilities of being a champion. And here now we have predict underscore probability. We wanna have the probability of the team being champion. Not just saying who is gonna be, but even a probability. So this in here, we're gonna, let me remove this for now. And now we can look at this. So here, we just wanna have a basic summary of some important statistical metrics that we can look into. And I will give you a few definitions of each of them as well, so that you know when to use them and when not to use them overall. So the accuracy is basically what everyone looks at when they train a machine learning model. Is how accurate is the model into answering the hypothesis based on the historical data and the features we're given it. At the ROC AUC, it's more a realistic approach into defining which are the true metrics and which are the false metrics. The log loss, usually, if you have a low log loss, it means that your model is making less mistakes overall. And we also have the confusion matrix, and confusion matrix also gives us the false negatives, the false positives, and those kinds of insights that you might use to really quickly spot if your model is performing well, overperforming, biased, and all these things. So here we're running, and we can already clearly see that we have an accuracy of 1, which is accuracy perfect, 100%. And why is it the case? It's because we're using features that directly can predict the outcome. So when we're using something like projected points, and we have the highest projected point usually lead to the team that is winning, not usually 100%. The points per match, the highest, it leads directly. It's like we've created the logic and the assumption here that these features ultimately will directly lead to the results. And when it was trained on previous data sets, they looked at the projected point and the points per match, and it directly gave us who was the winner of the championship. So that's normal to see it here. We can see the log loss is really low because our model is already kind of fitted. And we can see here in the confusion matrix that we have 190 teams. So we have, for the 10 first seasons, we had 200 teams. So 190 teams that didn't win and 10 teams that won the championship within the last 10 years, which makes sense. This is a perfect model in here. And usually, in most cases, you won't find it. But in our case in here, we've built it more into a predictive logic than a real machine learning problem. And in here, I'm just going to add these definitions. A precision, recall, F1 score, support, and confusion matrix. It's also good to understand these as a data scientist overall. So precision, as we can see in here, is out of all the times the model said yes, how many times was it right? That's important to know. The recall is out of all the actual yes cases, how many did the model catch? So there are slight nuances, and depending on your context, you might have some features that are more interesting than others. The F1 score is the one that is mostly used usually, and it's just a mix of precision and recall overall. So that's why a lot of people use F1 score. It's usually the most balanced result to look into. The support is the number of actual cases for each class label in your data. And here we have 190 that didn't win the championship and 10 that won the championship. Always good to have a visual of these things. And the confusion matrix is a table that shows what the model got right and wrong. And usually it's a very, very interesting report to look into in your machine learning projects. So we keep going in here, and now we're gonna predict the probability of becoming a champion. So we're gonna use predict_proba on the test data set now. We're on the test now, we're gonna predict on it, and we're gonna just predict who is gonna become a champion. So if we do just the first one, and here if we just open this, we're gonna see that it created a new column for us, win probability, as we can see in here. But in our case, what we're gonna do is that we wanna turn it more into a percentile. So what we do, we take that column, win probability, and we're gonna create out of it a column called win_probability percentage. So we get the percentage because it's better visually to see. And yeah, we just basically do multiply by 100 and we get that percentage. And if we run this one now, and again, if we look at df_tests, we can see here now that we have probability. So now if we do 20, we can clearly see that, if I zoom out a bit so we can see, okay, Barcelona has 70% chances to win the championship, whilst Madrid has 12.5, Atletico 8.3, and Athletic Club 8.3. So this gives us already a win probability of each of the 4 teams that we have on the top of the league. There are only 10 games left, that's why we see just a few teams that have the ability to win, and that's how you do it basically. And if we keep going a little bit, and I just want to see, instead of having that very huge data set in here I'm just gonna bring the data in a more pleasant way. I just chose a few columns to showcase in here, and I just did projected points in descending order. So we can see based on the projected points, we can also see the probabilities being assigned to them accordingly. There's a high correlation between them. And what we can do, obviously, to visualize this very nicely, we can just use again Plotly, my favorite visualization tool. And here what we can do, we can just have a bar chart where we're gonna basically just showcase these things, the win probability and the teams, and as easy as that. So on the x-axis we'll have the squad, y-axis will have the win probability. We're just having a color in here, we have a title. It's very easy, let me just run it in here. And we can see here clearly that we have Barcelona, the highest contender, Madrid following, Atletico Madrid following, and Bilbao in the same ranking here. And this was based on the past 10 years, plus features from this year and data from this year. And here, if you want to answer the questions that we were asking ourselves, we can just come in here and say, okay, based on our analysis, Barcelona has 70.8% chances of being the champion of this championship. Madrid has 12.5, and so on. And we can even look at who is at the 7th position of the championship. So if we look again here, we can see 1, 2, 3, 4, 5, 6, 7 for the Conference League, and it's more likely to be Mallorca. So we can say, okay, for the Conference League of the 7th position, Mallorca might be the team probably that is going to finish 7th based on our analysis and our assumptions, and the relegated teams will be Las Palmas and Valladolid, as we can see in here. And here we have it now. We did a full data science end-to-end project. We scraped our own data, we brought it, we cleaned it, then we went and explored our data set, visualized it. Before that, we've put our hypotheses and assumptions, then we explored the data, we visualized it, analyzed it, then we did a machine learning model using random forest classifier, and we use a probabilistic model in here so that we can predict who are the teams that are going to be ranked from 1 to 20 by the end of this season. And what we learned to use pandas, we learned how to scrape, we learned how to use Plotly and Matplotlib, we learned how to make hypotheses and put our own assumptions into a project, and we also learned how to analyze the data from start to finish. And with these tools, any projects that you can think about, you can go get your own data, bring it in, clean it, put hypotheses, explore it, analyze it, visualize it, and do your machine learning modeling. And if you're interested in another project where I went through a data analyst end-to-end project where I analyzed an art museum dataset, I'll link it just in here in the description below, or you'll find it somewhere in here. Thank you for watching.